In this activity, Gianna and I are going to show you how you can solve a free fall acceleration problem in which an object goes up and back down following in the shape of a parabola. We're also going to solve the problem when an object falls from a particular height. In this particular problem, we're going to look at how Flynn Rider, who will be courting Rapunzel, is going to determine how high Rapunzel will be, and secondly, if they fell out of the window, how fast they would be going on the way down. So we're going to suggest that you pause the video for a moment, read through the problem, and we'll see you on the other side as we solve this. Okay, as you read through the problem, what you would notice is that it said that Flynn Rider threw the rock from the ground up to Rapunzel's height. It came back down in a total of 3.4 seconds worth of time. We know that because the motion is symmetric, what we are going to realize is that it reached the top at the halfway point of this flight, and half of 3.4 will be 1.7 seconds. So it will serve us well to know that as we try to look for some variables to solve this problem. After we figure out the answer from this part of the problem, we're going to actually look at the falling condition in another picture in which Flynn Rider falls from halfway down the tower and Rapunzel falls from the entire height of the tower, and we're going to compare the two speeds that they would have. Now, logically, we would expect her to have a higher speed than he would because she's starting from a higher height, and she will accelerate for a longer period of time. And we're going to try to figure that out. Okay, our first step in this problem, just like any other problem, is to draw a picture representing what's happening. So in the first part, we threw the rock up in the air and it came back down. So Gianna's drawing a parabola here. And for this particular parabola, we want to know how high the rock went. So we're going to look for the delta y at the top. So we'll mark the top of the parabola as the spot that we want to find. Now, we know that the rock was accelerating at a rate of negative 9.8 meters per second squared, because all things that are in the air, unless there's a force acting on them, will accelerate at that rate. The v at the top, which will be the vf, would be 0. And we know that it's going to take 3.4 seconds to do the whole trip, but the time to get to the top will only be half of that. So we're going to go with 1.7 seconds for the time. Now, if you try to use the kinematics equations, one of the problems that we're going to have here, if we're looking for delta y, is that we are missing the vi, and the vi is necessary in most problems. So we're going to also look for the vi before we start. So we are going to put vi with a question mark too. Now, because vi is so important, the first thing we need to do is get the vi, because we would not be able to get the delta y without it, without making some assumptions. So we're going to use the kinematics equation of vf equals vi plus at, and we're just going to simply plug the numbers in, and we're going to leave the units out, knowing what the units should be at the end. So we have a vf of 0. The vi is what we're looking for. The a, like we said, is negative 9.8, with a time of 1.7. We do a little bit of algebra here, isolating the vi, moving the variables around. We will get a vi of 16.7 meters per second, meaning that that was the speed in which the rock was thrown into the air. Now, using that speed, that was a key piece of information, we can now solve the missing delta y by using the next kinematics equation. Delta y equals half, parentheses, vi plus vf times t. Plugging in the values that we had for this trip, we will have that delta y will equal, we can turn a half into 0.5 if we like, and our vi we said was 16.7, our vf was 0, and our time was 1.7 to make it to the top. Doing some algebra, we would find out that the delta y in this case would be 14.2 meters, indicating that it rose 14.2 meters up into the air. We're going to use this piece of information in the next part where we solve for their speeds as they fall. Okay, now that we have solved the height of the tower, now we need to know what their speeds will be when they both fall off. We know that Rapunzel is going to fall 14.2 meters. But because she's going to start at what we consider the origin, her displacement will actually be negative 14.2 meters because she's going to be below where she started. We also know that she's going to accelerate at negative 9.8 and that she's going to also start from rest. So her VI will also be 0. Using these values to find the VF, we should be aware that the kinematics equation that we will use is going to be VF squared equals VI squared plus 2A delta Y. And then finally, we'll plug our numbers in. In which VI is 0. We have 2. A is negative 9.8. And delta Y is negative 14.2. And to save you the pain of all the algebra, we'll just give you the final answer here in the calculator by square rooting everything. That would give us a VF of negative 17 meters per second. Okay, to save you a little bit of time, we're going to assume that all the conditions for Flynn are the same, except for that he's going to fall from half of the delta y, because he's only going to fall from half of the tower. So we're going to use the same equation, VF squared equals VI squared plus 2AY. And all we're going to really change is the delta y. So we'll place the numbers in there, and then you can run it in the calculator and see what you get. So if we do this, we'd say VF squared equals 0 plus 2 times negative 9.8 times negative 7.1 because it's only half. And if we run it through the calculator, after square rooting both things, sorry, we went off the page just a tiny little bit, and we would get a VF of negative 12 meters per second, which is what we expected. We expected him to be falling at a slower speed. Now it's a negative speed, but it's still slower. And the question actually asked what was their difference in speeds. So if we look, if she was going 17 and he was going 12, then the difference between the two was actually just 5 meters per second. All right, we hope that you learned a little bit about how to do these problems. Make sure that you do your homework, and we'll discuss this in class. Thank you.